Hello everyone, I'm Shane Brennan, I'm Chief Executive of the Cold Chain Federation, and I'm today in Bury St Edmunds with Clive Thornley of Styne Refrigeration. And this is our first ever video recording of the Cold Chain podcast, which is a really exciting innovation. So today I'm going to be talking to Clive about the technology solutions that they're developing that are giving real potential for the cold chain in making a massive step forward on the road to net zero. So really keen to get under the skin of that, understand what technology is and how we take it forward. So before I do that, I'm going to quickly ask you, Clive, to introduce yourself.
Hi, I'm Clive Thornley, as have you said, Styne Industrial Refrigeration. Styne Industrial Refrigeration are part of the Styne Group. We've got three companies in the group. We have an electrical contracting company, an engineering company, and as the name suggests, a refrigeration company. We're based in Suffolk, and our focus, if you like, as a refrigeration company, is all about natural refrigerants and the impact we can have on their uses in the industry to help the industry get to the net zero carbon target that we're all committed to getting to. When we set the company up, it was the forefront of our mind, to be honest with you, how we can reduce the amount of power that's used to run refrigeration systems. So the whole ethos of the company is to reduce the footprint, both of our carbon footprint, both of our projects and of the impact our finished products have on industry. So it's all about carbon reduction for us.
And I think my experience, obviously the Cold Chain Federation was created 2.5 years ago out of FSDF with a mission around being the network for discussing the road to net zero. My experience the last 2 years has been, we've had quite a lot of good conversations about it, but fundamentally the focus of the industry has been on immediate issues around the pandemic, around coping with Brexit and those issues, and particularly right now the energy market price spikes. I guess the question I already have for you is the solutions that you're providing to the market, are they relevant for the sort of that headspace today, those worries that businesses have got right now, as much as they are for the sort of long-term road towards net zero?
Yes, definitely. There's possibly the biggest challenge, I think, outside of the crises, as you just mentioned, that I believe will pass, are the control of energy and the amount of energy that each one of these buildings uses. And that's never going to go away, whether we've got enough drivers or whether we've come to a trade agreement with Europe is one thing, but with the cost of energy consumption in the buildings that we have isn't ever going to go away as a challenge. It's been a challenge since the day they were all put up. It's still a challenge today. And one of the challenges that we have as a company is to reaching out to the members and trying to introduce the option of overcoming that challenge, and that's the job. And I think that's really what's really interesting and what really strikes me about the way you approach it. And that idea of resilience, I think, is really important. How you marry the idea of resilience in your business to carbon off neutrality. Can I ask you then, what is the game-changing nature of technology you're talking about? Okay, so we're refrigeration engineers, and your perception, dare I say, is probably that a refrigeration system is something that's locked in a plant room at the back of a building, makes a fair bit of noise, generates a fair bit of heat, and out of that you get a cold room at the end of it, which is great, and that's 99 times out of 100 what happens. All these systems use ammonia, or the vast majority of them will use ammonia as a refrigerant. It's the refrigerant of choice in our industry. Luckily for us, it's a natural refrigerant, so it fits in exactly with our ethos. What we're proposing, or what we have at our disposal in form of technology, is a piece of equipment called an absorption chiller. Now, absorption chillers are widely used both in the commercial world and in industry at higher temperatures. And higher temperatures are important, which is why they're not coming to the Cold Chain Federation sphere of influence.
And I guess when you mean industry, you mean sort of buildings that need air conditioning?
Basically, yes, yeah. A notable example would be the Shard.
Yeah.
There's a number of absorbers in that building. Now they run on a refrigerant called lithium bromide. Great, it's fine, lithium bromide water combination, and because they've got water in them, they're really, really good down to about a maximum of plus 6 degrees, which again for the rest of our members of the Cold Chain Federation is not really terribly suitable. There's not that much application for a plus 6 degree room. Where our product is, should we say, niche, suitable, call it what you will, it uses ammonia, which, as everybody who uses ammonia in a refrigeration system will know, is good down to around about the mid minus 30s, something like that. So with the judicious application of a heat source onto an absorption chiller, we can facilitate an existing store or a new store that wants to run a low temperature application, say minus 25, minus 30, with very, very, very little power consumption. And when I say little, I mean around about 90% less than you're currently using.
Because you talked about a heat source. Yes. Obviously, what normally a heat source would be basically gas, electricity to basically warm it up.
Yes, I mean the obvious everybody's perception of a heat source is a flame. Yes, so there's two ways we can apply this heat source currently. Number one, we could install today, right this second, a carbon neutral biomass boiler system. So you feed it with replenishable, sustainable fuel. You get a heat source at the other end, which uses its heat to drive the absorption chiller. So straight away you've got almost a carbon neutral refrigeration operation there. That's good in as far as it goes. One of the challenges around that is all it is doing is driving your absorber. So as a project, and there's the other side of the coin, as far as everybody who's got a business is concerned, the product is relatively expensive, as a relatively slow cost recovery period, return on investment and ROI. What's possibly a better solution, or a more usable solution for the next 5 or 10 years, is the implementation of a natural gas powered CHP engine, a combined heat and power engine, because instantly that will give you self-generated electricity at a price you can control, and you can use the heat from that combined heat and power engine to run your absorption chiller. So the sort of return on investment figures on that sort of project really quite prompt.
Yeah.
So,
and I guess one of the problems we've had in refrigeration generally is people have been talking about combined heat and power a lot over 10 years maybe, but no one's really known what to do with the heat in refrigeration. And so I guess the loop that you're closing with the absorption chiller is you can use the heat from the byproduct of refrigeration to power the absorption chiller, that then therefore creates a cycle and a circuit that's beneficial.
So if you were to buy a really good CHP engine, a combined heat and power engine, your efficiencies would be around 45 to 50%. If you then put an absorption chiller in tandem with that combined heat and power unit, then that efficiency rises from 45% to between 88 and 93%, which is significant.
Which is game changing in its own right.
It is.
But again, then project forward for me though. I mean, am I right in saying that actually you can go one step further in the future, conceivably, using hydrogen? Is that right?
Definitely. The hydrogen economy, as you observe, is evolving. Now, we've teamed up with a couple of combined heat and power engine suppliers, specifically around the fact that the engines that they're producing are combined heat and power hydrogen ready units. So install one today, does a fair bit for your bottom line in terms of cost savings, doesn't do a great deal actually for your carbon footprint of your business today. But all the projections from government, and you'll probably know more than me on this, all the projections from government that the hydrogen economy has to take over from the carbon economy in the next 10 to 15 years. Now, I've heard a lot of people say, well, hydrogen is difficult to manage. That's not going to be our problem to manage. It's going to be in the same way we don't manage natural gas now. It just comes out of a pipe in the ground. So the management is done away from site, the consumption's done on site. And if you can think about the fact that we would be in 10 years time, 12 years time, using a combined heat and power engine that runs purely on hydrogen, what that has done for your business in terms of a carbon footprint is enormous.
But why? I think it's quite a strange concept for someone to think about buying something today for a hydrogen source that everyone's kind of knows is coming but doesn't really know. But I think what really strikes me what you're saying is you can do both. You can get the benefits in the short term and also be ready for that longer term, which sounds really attractive to me.
Definitely. The internal combustion engine will run on hydrogen almost as well as it will run on natural gas. It's very, very little modification required.
But let's take the government at their word and be sort of realistic about timeframes. So we might have genuine use of hydrogen within 10 years. If I'm buying a refrigeration system today, would I not be thinking about what it might do in 10 years' time? It feels like quite long into its life cycle.
Not with an absorption chiller. Again, and I refer back to the comment I made earlier, whereas hitherto most people's perception of a refrigeration system is one that got lots of moving parts, generate lots of heat. Your CHP engine takes that role now, and the absorption chiller only has one moving part, has a small circulation pump, and outside that everything is done with heat exchangers. So realistically, the life cycle of your absorption chiller is going to be knocking on the door of 20 years, and possibly even longer with control panel modifications, software upgrades and that sort of nature. But the actual technology inside an absorber hasn't changed in the last 100 years. It's been the same. The fact that we're using an ammonia on a commercially available platform is the only thing that's changed.
And what about the difference in sort of capex cost? I mean, say I was starting today building a new cold store. What's the difference between the sort of system you're describing in terms of upfront cost versus what we're more used to, sort of more vapor based systems?
Extremely similar. Yeah. Extremely similar. The only exception being that the absorption chiller or the CHP absorption chiller combination will have a predefined underwritten return on investment. Compared to something that just consumes, which is a vapor compression system. So there is a consideration to be made. If you're planning a nice and shiny new greenfield site, then not considering a CHP absorption chiller combination would be quite an omission, just to be frank at the moment.
But what's the catch? So surely it all sounds a bit too good to be true, Clive.
Yeah, but people always say that. It is too good to be true. And I'm not sure that there is one. I can't see one at the moment. Currently, there's 25 of these units running across Europe. They're going in at the rate of one every 6 months at the moment. Yeah. They wouldn't be going in at quite that rate if there was a catch. So I completely see where you're coming from, and I think is one of the issues really a sense of people sticking with what they know rather than embracing something that feels quite significantly different to what we're used to installing and maintaining and running in our cold storage businesses. I think that's a pretty good point. I mean, I think refrigeration's a pretty arcane art. No one really knows how it works. So if you get someone who you trust to say, actually, this worked last time, so do it again, there's a tendency to think along those lines. And this is properly out of the box thinking for a lot of people who aren't refrigeration engineers. Dare I say, even some that are think about this as being out of the box thinking, because it is, in terms of what we're used to, radically different. But the take up is
really encouraging.
It's really encouraging, yeah.
And I guess the other thing that I've genuinely noticed in the industry is that we are moving to a model where people are genuinely thinking about the life cycle we pay back on their product on these institutions rather than just the capex up front.
Yes.
And I think, and as you say, the capex up front on comparable systems is very, very similar in the model you're talking about. But the ROI over the medium term and short to medium term is really attractive.
Yes.
That is increasingly how people see these projects, isn't it?
Yes. And also the total cost of ownership over the lifetime of the machine, because you look at TCOs on vapor compression system, reasonably cheap in the short term, but over a period of time just does this and this and this. whereas the total cost of ownership on an absorber remains pretty much static all the way through its lifetime. And it doesn't wear out, I suppose is where I'm going with that.
Yeah, and then let's talk about this idea of the road to net zero. And that's where you started from, and that's where obviously we come at from a federation point of view as a kind of mission of our organisation. How do you think businesses are embracing that right now in the industry? Do you think? What's your feeling on the extent to which this is a driver of purchase? The idea of having something that's contributing to a road to net zero.
I think one of my favourite sayings, and we use it a lot on our web material, is that green is a trend and sustainability is a mindset, and it's very, very true. And a lot of businesses aren't thinking in a sustainable way. I think that's the biggest thing for me here, is that we look at how we can reduce our carbon footprint in this instance, rather than how we can invest, how we can use our funds wisely in a sustainable way to get our business to net zero. And I think that's the difference in thinking. I think there's a thinking around what we can do today to reduce the carbon footprint of this building by tinkering around the edges.
Yeah. No.
If I'm being blunt, I think.
I think that mindset point really resonates with me too. So can I ask you then about if a business is looking at this issue and is interested in what they've heard today, or they're just generally looking at it in their business, what's the right point to engage in a conversation with you? What sort of project stage should they be at to come and talk to you?
When you start thinking about it, I think is the thing. With the greenfield site at design stage, even if you have an existing building that's running on ammonia, and most of our colleagues in the cold chain probably should be running on ammonia if they're not, and I said that in the webinar that we did last year. That's the big step to reducing your carbon footprint, putting ammonia and a secondary in. But if you've got a building that's running on ammonia now and it's say 30 years old, to look at this way of reducing your incoming energy costs and reducing your carbon footprint today, great. We can do that. It's available now. It's doable. If you're even if you've got something that the building's fine but the refrigeration system needs updating, then it's a good time.
And you shouldn't be put off by the fact that it's genuinely quite new technology, because it does fit around the existing infrastructure of your refrigeration system, and it can.
Oh, definitely. Yeah. Yes, we're looking at a couple of projects at the moment which are out and out retrofits. Yeah. Just plug into your existing system and take the load off it, and reduce your power consumption again by around about 90%. It's significant numbers. It
really sticks out to me, this idea of thinking differently and creatively about the engineering solution, the technology solution, thinking about the business case of sort of comparable cost upfront and of equipment.
Yes.
And then the ROI, but the ROI certainty that comes from taking greater control over energy input and the resilience of your operations through something like this. So I think there's definitely a lot of conceptual reasons why this is the sort of thing that business should be engaging with. I guess the proof is in sitting down and talking to you and seeing for themselves how it works, which you can do.
Yes, of course and we will happily do. Yeah. And I think one of the other considerations that we sort of touched on was that if you were to install a combined heat and power system and generate your own power on site, a lot of the Cold Chain Federation members are moving on to more electrically hungry vehicles. I would suggest the ability to be able to generate your own power to charge those at night under your own control, or even during the day. It's got a lot of advantages to it.
Absolutely. There's this idea that there are businesses out there that would say, well, if the grid's going to go electric, going to go net zero through renewable power generation, so the power I draw off the grid is going to be green. What do I need to worry about it for? Well, the reality is the amount of power that the grid's going to require is so significant, and we look at the price spikes we're seeing today. That is going to be a reality of the road to net zero.
Yes, absolutely.
So the more you can be resilient in your own operations,
Definitely.
the better. So I think that's a really kind of key note and a good note to end on.
Yeah.
Clive, thank you very much. Thank you for hosting me here at your offices, and thank you for sharing your insights, which obviously we'll talk about more over the course of this year. It's brilliant to have you as part of the conversation around what we're trying to achieve in the Federation. So that's the end of our podcast. Thank you very much for taking part in our first ever video podcast. If you haven't yet, please subscribe to the podcast and make sure you're listening to the content. Much more great conversations like this to come. And I look forward to talking to you again. Thank you very much.